today we are in 4-5 day 1. Oh, let me get rid of that. Okay, 4-5 day 1. And this section is going to give you all of the derivative rules for the inverse trig functions. So let's quick review what an inverse trig function does for us. If we had, say, the cosine of some angle equal, and we knew the ratio, say it was 0.6432. What we did last year in trig was we did the inverse cosine to figure out what that angle measure was. And I never wrote it like this, but what we're actually doing, what we do to one side, we do to the other. We take the inverse cosine of this, and then the inverse cosine of that decimal. What happens here, these two trig functions cancel each other out, and it solves for the sine. And then inverse cosine of 0.6432, if you typed it in the calculator, it would give you some angle measure back. Not that I have the calculator handy to do that. The answer is not important, just that the inverse trig functions give us back angle measures if we know the ratio. What we want to be able to do is do derivatives of the inverse trig functions. So I'm going to take you through, step by step, 3 of the discoveries of the derivative rules, and your partner quiz tomorrow is going to be to do the other 3. So it's going to be a step-by-step process, and it's the same all the way through. So we're going to work with, I'll do 3 of them. The first one's going to be inverse cosine of u, where u would be some ratio. But anyway, the first thing you want to do is get out of inverse cosine. And the way you eliminate an inverse cosine is to do the cosine of it, because an inverse of a cosine and a cosine of an inverse, they will cancel each other out. So what you're going to do is take the cosine on both sides and simplify. So on the left, you're going to have cosine y equals, and over here, the cosine and the inverse cosine cancel out, leaving you with the u. So what this is telling me is the cosine of angle y is equal to u. And cosine's a ratio, you can think of it as over 1. Now at this point, you're going to want to sketch a triangle in quadrant 1 where the angle is represented by the y. And because we know the cosine ratio is u over 1, and remembering your SOHCAHTOA, because cosine is u over 1, I now know if I'm standing at y that the adjacent side is the u and the hypotenuse is the 1. So I can label the triangle with the adjacent side u, hypotenuse 1. I can do a little Pythagorean theorem to get this opposite side. I'm just going to put a little placeholder there, a little b maybe. I'd use O, but it's going to look like a 0. So doing a little Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared, u squared plus b squared equals 1 squared. Solving for the b squared equals 1 minus u squared. So b will equal the square root of 1 minus u squared. So that's what's going to go on this side here, is the square root of 1 minus u squared. Okay, so now that we've got the triangle, now we're ready for derivative. We know how to take the derivative of cosine. We've spent 2 days on it. The derivative of cosine is negative sine. So negative sine of the angle times the derivative of the angle. And this is called implicit differentiation. The derivative of a y would be a 1, but it's going to be a 1y prime. Over here I've got a u. The derivative of u is 1, but times u prime. I know this is a little bit different. It's called implicit differentiation. It's actually the next section in here, so I kind of think this is misplaced, but if you just think of it as a rule and go with it, anytime you do the derivative, you just stick whatever the letter is, a prime with it, we're good to go. Okay, our goal is to solve for y prime. Because I had y equals inverse cosine, I want y prime. I want to know what the rule is going to be. So if I solve for y prime, I'm going to divide by, because it's being multiplied here, the negative sine y on both sides. So y prime equals u prime over negative sine y. Okay, the goal now is to get rid of the y's in terms and get all u's here. Well, all I've got to do is go to the triangle and get the sine ratio for angle y. So the u prime is going to stay. The negative is going to stay. Sine of y, so I'm going to go to angle y, stand. Sine is opposite over hypotenuse. Well, opposite from y is the square root over 1. So it's just the square root of 1 minus u squared, then over 1, but that's not necessary. So we just came up with the derivative rule, this was y prime, for inverse cosine. And typically you're going to, well, I'm going to leave it just like that actually. Oh, I wrote it differently on my sheet. I pulled the u prime off to the side and put the negative up in the top, so it was negative 1 over the square root of 1 minus u squared times u prime. But that u prime will end up in the top. So add that to your blue sheet. I've already got it on mine. All right, so we're going to go through another one. We're going to do 3 of them together. The next one we're going to do is inverse cotangent. I'm going to start a new page just in case I run out of room. So y equals inverse cotangent of x, actually u, and we're going to develop the derivative rule. So first thing you do is eliminate this inverse by taking the cotangent of it. So whatever I do to one side, I'm going to do to the other. So on the right hand side, the cotangent and the inverse cotangent cancel each other out and it leaves you with the u. This side's just going to stay cotangent of y. So that's your first step, eliminate the inverse function. After you do that, sketch a triangle, because you're going to use it at the end. The angle is y. Okay, the cotangent ratio is u over 1. Well, cotangent is tangent flipped over. So TOA would be opposite over adjacent. So cotangent is going to be adjacent over opposite. So this is my adjacent, this is my opposite. So if I'm standing at the y, the adjacent is the u, the opposite is the 1. And I have to do a little Pythagorean theorem to get the missing side. So it's leg squared plus leg squared equals hypotenuse squared. If you need to write that out, u squared plus 1 squared equals hypotenuse squared. I can see that the hypotenuse is going to be the square root of u squared plus 1. Okay, now we go into derivative. We've got a regular trig function that we know that we have a rule for. Cotangent's derivative is negative cosecant squared of the angle times the derivative of the angle is going to be y prime, 1 y prime. And on the right, the derivative of u is 1 u prime. So after you do the derivative on both sides, you now solve for y prime. So we're going to divide by negative cosecant squared y, negative cosecant squared y, y prime, e prime over negative cosecant squared y. Okay, the only problem with our derivative is it has u's and y's. We want it just with u's. So you could go and get the cosecant ratio right here. Or you can think of this, if you remember your trig properties from yesterday, as, I'm going to bring the negative up, negative 1 over cosecant squared y times the u prime. Just pulling the u prime off to the side, bringing the negative up. This is one of your identities. This is cosecant flipped over. Cosecant flipped over becomes sine. So this is negative sine squared y times u prime. Now I know I want to go to the triangle and get the sine ratio and square it. So, not the negative doesn't get squared though. So stand on y. Sine is opposite over hypotenuse. So the opposite is the 1. The hypotenuse is the square root of u squared plus 1. I've got to square that, and then it's times u prime. Notice the negative was not a part of it, just the sign is being squared, not the negative. So square the 1, square the denominator. Negative is still here. Remember, when you square a square root, they cancel each other out, and you just get the stuff underneath. There is your inverse cotangent derivative. When y is inverse cotangent, that's your rule. Okay, one more, and then I'll summarize the steps that you're going to be repeating tomorrow with your partner. And let's do secant, inverse secant. So we'll start with y equals inverse secant of u. Okay, step 1, get rid of the inverse. To do that, you just take the secant on both sides. On the right, these cancel each other out. Leaves you with a u, secant y. Now sketch your triangle. The angle is y. That is a ratio if you put a 1 underneath it. And secant is cosine flipped over. Cosine is ca, adjacent over hypotenuse. So secant is going to be hypotenuse over adjacent. So the hypotenuse is the u. The adjacent will be the 1. Doing a little Pythagorean theorem again. 1 squared plus b squared equals u squared. B squared equals u squared minus 1, subtracting 1, and then square root. So b will equal the square root of u squared minus 1. Okay, so get rid of inverse, sketch a triangle, take the derivative. So derivative of secant is secant of the angle times tangent of the angle times the derivative of the angle, which is y prime, 1 y prime. Derivative of u goes to u prime. Now solve for y prime. So you want to kick both of these to the other side, and you do that by dividing. By secant tangent. Divide by secant tangent. So y prime equals, I'm going to break this apart, 1 over secant, which I know I can simplify, 1 over tangent, and then u prime. 1 over secant, that's secant flipped over, that goes right back to cosine. 1 over tangent is cotangent. Now all I've got to do is get rid of my y's by going to the triangle and getting the ratios in terms of u. So looking, standing on y, cosine is adjacent over hypotenuse, and cotangent would be the opposite of TOA, so it's adjacent